Welcome to the DIY Honda Garage channel. DTC P0793 refers to an issue with the intermediate shaft speed sensor, A, indicating a circuit malfunction characterized as no signal. This code primarily pertains to vehicles with a continuously variable transmission, or CVT, like the Honda Civic 2016 to 2021. The intermediate shaft speed sensor monitors the rotational speed of the intermediate shaft, providing critical data for the Vehicle Control Module, or TCM, Transmission Control Module. If this sensor fails to send a signal, it can hinder the vehicle's performance and efficiency. It's essential to note that this issue is rooted in electrical problems and not mechanical faults in the transmission itself. This distinction is crucial when beginning diagnostics, ensuring that technicians focus on the electrical circuit connecting sensor components and the TCM. The intermediate shaft speed sensor is a critical component located near the CVT assembly in the Honda Civic models from 2016 to 2021. This sensor is responsible for monitoring the speed of the intermediate shaft, which plays a vital role in the operation and functionality of the CVT. By relaying precise speed information to the TCM, it helps manage the engine's performance, ensuring smooth shifting and optimized fuel efficiency. If this sensor fails to operate correctly, it can lead to erroneous readings, prompting issues such as DTC P0793. These electrical circuit problems can stem from faulty wiring, poor connections, or component failures within the sensor. Hence, understanding the sensor's role and positioning aids in effectively locating and addressing the source of the fault. The possible causes of DTC P0793 are primarily rooted in electrical circuit issues. An open circuit or short in the wiring connected to the intermediate shaft speed sensor can disrupt proper signal transmission. Additionally, bad connections, which might include loose terminals or corroded connectors, can hinder effective communication between the sensor and the TCM. It's vital to examine these components closely, as intermittent errors can lead to erratic performance without revealing clear faults. Lastly, while mechanical issues are not responsible for this DTC, a faulty intermediate shaft speed sensor can also be the core issue, needing replacement to resolve the signal problem. The symptoms of DTC P0793 are indicative of transmission-related performance issues within the Honda Civic. Drivers may experience unresponsive throttle, meaning that the vehicle fails to accelerate as intended or hesitates during shifting. This can result in a sudden loss of power or poor vehicle responsiveness. Additionally, the check engine light will typically illuminate on the dashboard, alerting the driver that there is a fault in the vehicle's system. These symptoms are often accompanied by erratic behavior while driving, such as unexpected gear changes or engine misfires, significantly impacting overall driving experience. It's crucial to diagnose the issue promptly to avoid further complications or damage to the transmission system. The first step in troubleshooting DTC P0793 involves preparing the vehicle for diagnostics by turning it to the on mode and employing the HDS, which stands for Honda Diagnostic System, to clear the existing DTC. This helps to reset the system and can sometimes resolve minor errors or glitches. It's then crucial to raise the vehicle securely on a lift, ensuring that all four wheels can rotate freely, thus providing an accurate test environment. Following this, the engine should be started, and the Vehicle Stability Assist, VSA, must be disabled. If the speed exceeds approximately 31 miles per hour, it's essential to enter VSA maintenance mode. By running the vehicle in D position at speeds over 19 miles per hour for at least 30 seconds, diagnostic checks can be performed to see if DTC P0793 reappears, verifying the failure condition for further analysis. In the second troubleshooting step, the vehicle should be turned off completely to begin checking for possible areas of failure. The next action involves disconnecting the CVT drive pulley speed sensor 3P connector, which allows access to conduct electrical tests without interference. After disconnecting, the vehicle is turned to on mode. A multimeter can then be used to measure the voltage between the designated test points. Specifically, test point 1 corresponds to the CVT drive pulley speed sensor connector number 1, and test point 2 corresponds to body ground. The measurement should reveal around 5 volts. If achieved, this indicates that the electrical circuit from the TCM to the sensor is intact, allowing the technician to proceed to the next diagnostic step. Moving on to step 3, the focus shifts to verifying the voltage on the VCC1 line, which is crucial for the functionality of the speed sensor. The technician is required to measure the voltage again between designated test points while ensuring the CVT drive pulley speed sensor connector remains disconnected. Test point 1 will be connected to the CVT drive pulley speed sensor 3P connector number 3, while test point 2 continues to reference body ground. Achieving approximately 5 volts implies that the VCC1 wire is functioning correctly, guiding the technician to the next step. However, if the voltage is absent, an open circuit issue is present, necessitating repair of the VCC1 wiring between the sensor and the TCM. This troubleshooting methodical approach ensures any faults are localized effectively. Step 4 involves checking the CVT drive pulley speed sensor directly to ensure its operational integrity. Again, with the sensor connector disconnected, the technician measures the voltage between specified test points. Test point 1 corresponds to the CVT drive pulley speed sensor connector number 2, and test point 2 to number 3. If the measurement yields around 5 volts, the sensor is deemed functional, and the technician can proceed to inspect the wiring instead. However, if the voltage falls short, this suggests a defective sensor, warranting its replacement to restore proper signal functionality. This step ensures that if there is a failure, it's pinpointed to the sensor, a key component in the overall transmission operation. In the fifth troubleshooting step, the vehicle should be turned off again before disconnecting the 50P connector associated with the TCM. This procedure prepares for a continuity check that assesses the integrity of the NDR PWM line, crucial for the intermediate shaft speed sensor to communicate with the TCM. The technician checks for continuity between specific test points, comparing test point 1 associated with the speed sensor 3P connector, number 1 against body ground. If continuity exists, it indicates that there is a short to ground in the NDR PWM wiring that requires repair. Conversely, if no continuity is detected, this suggests that the NDR PWM line is intact and leads the technician to the final troubleshooting steps. The final step in troubleshooting for DTC P0793 revolves around confirming the integrity of the NDR PWM line again, particularly between the CVT drive pulley speed sensor connector and TCM. The technician checks continuity between the sensor connector number 1 and the TCM connector number 28, while ensuring both connectors remain disconnected. If continuity is present, the NDR PWM wire is functioning correctly, prompting the technician to consult authorized service information for additional guidance related to the DTC or consider substituting a known good TCM to test the system. Should replacing the TCM eliminate the DTC, it indicates the original TCM was defective and should be replaced. If there is no continuity, it strongly suggests an open circuit fault in the wiring, necessitating repairs for proper sensor operation. Upon completing the troubleshooting and repair process, it's crucial to perform a final verification to ensure that the issue has been resolved effectively. Start by rechecking all connections throughout the intermediate shaft speed sensor and TCM wiring to ensure integrity. Once confirmed, the system should be scanned with the HDS to confirm that no DTCs are present, particularly DTC P0793, which would indicate a successful repair. Additionally, a test drive of the vehicle is recommended to simulate driving conditions, ensuring the transmission operates smoothly without any irregularities or warning lights reappearing. This thorough verification process allows the technician to affirm the successful resolution of the fault and ensures the vehicle is safe and ready for normal operation. Preventive maintenance is essential to ward off future occurrences of DTC P0793. Regular inspections of the electrical connectors and wiring associated with the intermediate shaft speed sensor and TCM should be scheduled to identify any signs of wear, corrosion, or loose connections. It's equally crucial to monitor the performance of the speed sensor during routine vehicle checks to ensure its reliability remains optimal. Should any issues arise, addressing them promptly can prevent further complications or extensive repairs down the line. Furthermore, introducing an annual electrical system inspection could be beneficial, ensuring all components function harmoniously, reducing the likelihood of future DTCs, and enhancing overall vehicle reliability. In conclusion, understanding DTC P0793 and its implications is crucial for effective vehicle maintenance and repair. This code serves as a flag for electrical issues relating to the intermediate shaft speed sensor, necessitating a systematic troubleshooting approach focusing on wiring and connector integrity. By scrutinizing the sensor's operation and associated electrical circuits, technicians can accurately identify and rectify faults leading to this DTC. Moreover, performing regular maintenance and monitoring sensor performance can significantly mitigate the chances of encountering this or similar codes in the future. Ultimately, establishing a proactive maintenance routine will enhance the longevity and reliability of the Honda Civic CVT system, ensuring a smoother driving experience. Please like and subscribe to the channel. See you next time!